This is the third video of our tutorial TP-Link router analysis. We focus on the chipset on the printed circuit board and on dumping the firmware from the flash memory. So let's get started. As you have seen in the previous video, this is the front side of our router. Actually, we can go to the camera feed and you can see here these four chipset here. 1, 2, 3, and 4. We are interested in this chipset. On the top of each chipset, you will see the manufacturer name. And then the second line, this is the part number. We will use this information to search online or maybe visit the manufacturer's website to find the data sheet of each of these chips. Why we need the data sheet? Because actually the data sheet provides us with detailed information about the component and the pin configurations, even the electrical characteristics. This is important for understanding and even interfacing with this component. I followed this process for all the chips here, and I found the data sheet for all of them except for the Wi-Fi. So let's go back to our presentation. So here is the back side of the router. There is no any chips here, and here we start with our chips. So the first one is from XMC manufacturer. This is a NOR flash memory, and I found the data sheet here for these chips. And then the second one, this is from ASMT. This is a DDR2 RAM, and also the data sheet for it is available online. The third one, this is from MediaTek, and this is the only information I found that it's a Wi-Fi chipset. However, there is no data sheet available, at least until now. The fourth one, it's also from MediaTek, and this is the system on chip for this router. So this is the brain of this router, and also I found the data sheet for this. So at the end, this how our router looks like. Now we found the data sheet for all of this chipset. However, we are interested in dumping the firmware, so that means we are interested in the XMC NOR flash memory. Why? Because usually the SoC or microcontroller use an external flash memory to store firmware, and during the boot time the microcontroller will copy this firmware from the external memory to the internal memory, internal RAM, most probably using SPI communication. So let's take a look on the data sheet. Here I have it here. We are interested in two things. First, we need to look for a connection diagram, and as you can see, it is here. So this specify how the functionality of all these pins for this chip. And note here, this what is called as the orientation mark, where when we want to map those pins to our chip on the board, so we will use this orientation mark. So here you can see the functionality of each pin. This is the SPI interface. So the first one, chip select. When you see this forward slash, that means this is active low, and the chip select is kind of enable signal. So when it's selected, then that means now the microcontroller communicate with this chip. The second one is the data output. So this is the output of this flash memory. The third one, this is write protection. We are not interested in it here. Then we have the ground, and here we have the VCC. The reset or hold, also it's not interesting for us now. And then we have also the clock and the data input. So this is what's coming from the microcontroller to the chip. The second information we needs to know, because there is a VCC, we need to know the operating voltage. So I can search for voltage, and I can see here, okay, that's the one was before, here, full voltage range from 2.3 to 3.6. We want to know that because we want to dump the content of the flash memory without desoldering the memory chip. So we need to supply this voltage to the chip, and now we know exactly how much we need to supply to the chip. Okay, so now I have the information I want. Let's go back to our presentation. As you can see here, that's taken from the datasheet, the SPI interface, as I mentioned, and the voltage range. So what I did here, I mapped exactly those pins to the chip I have on the board using again the orientation mark. Okay, what tools do we need in order to communicate with this flash chip? We need to use at least one of these board. This is known as bus pirate, and this is Hydra bus. Both of them are well known in the industry. This bus pirate, in this video I will use bus pirate. So here it provides a kind of interface to talk with SPI supported device. What we need also, we need either one of these. Here, this is known as SOIC 8 or this is known as IC hook cable. I will use this one to connect to the chip. For some reason the clip I have didn't stick correctly on top of the chip. And of course we need a software. So in this case we will use FlashROM. FlashROM, it's open source, well-known tool that will allow us to send the command and read or write from the flash memory. Finally, here we have the connection. So what I did here, now you can see the chip select going from our chip will go to the chip select on the bus pirate board. Then the data out from the XMC chip will go to the master in, because this is coming from the chip to the bus pirate, so that's why it will go to the master in. And then the ground to the ground, here I have the VCC. Bus pirate usually provide two VCC, either the 5 or the 3.3. Now we know we need to use the 3.3. The reset, I will not connect it. Then I have the clock, it will be connected to the clock. And finally here I have the data input, and that will be connected to the master output on the bus pirate. We are ready for a live demo, so let's jump to the camera. As you can see here, I added, this is my bus pirate, and it is connected to the XMC chip. I used the exact color for the cable as I've shown you in the connection diagram. And also notice now that bus pirate is connecting through this cable to my computer, and also notice that the router doesn't have any power supply. So as we mentioned, now the bus pirate will provide the 3.3 voltage to the XMC. So now let's jump to the terminal. Let me first connect the bus pirate to my computer. You would see here a light, here, and actually if I run list USB, you would see here it's as a UART, because also I can connect to it. Maybe let's do bcocom, and if this is on the TTY USB 0-B, and I know the baud rate 11.5200. So now I am on the bus pirate. If I type M for a menu, you can see here that this is all the protocols that bus pirate support. One of them is number 5, the SPI serial peripheral interface, and that's what we will use to communicate with the XMC chip. Actually, this is another way here to communicate directly with the chip, but we will not use it in this video. We will use flash ROM. Also, let me show you. If I type flash ROM dash L, it will list all the supported flash. That would be a lot, but maybe we can grip on in this case XMC, and you see it support a few of XMC. Okay, so now we need to read the flash memory. So what is the command for that? It is the following. So here the flash ROM, then I need to specify the programmer. In this case, this is bus pirate SPI, and this is a device on the USB 0. And of course, I need to read, and I provide only the name of the firmware I want to read. So once I hit enter, you notice here it found XMC flash chip, and this is the chip number. And if we see here now reading flash memory, so now it's reading. I don't know if this is clear here, but you see now the lid is blinking because now it is reading from the flash memory. This will take a few seconds based on the size of the flash memory, so we will wait until flash ROM finish reading the firmware. Okay, it seems it's done. As you can see here, reading flash done. Actually, it took around 2 to 3 minutes, but now we have the flash. The firmware, actually, we can run bin walk on our TB-Link underscore firmware, and you see it detected boot, LZMA compressed, and the Squatch file system. That will come later in our next video. So now we have the firmware dumped completely from the flash memory. Let's go back to our presentation. So yeah, we did the lab demo. That's exactly the connection, and this is when we dumped the firmware. So as a summary, at the end of this video, we have 4 chips, one NOR flash memory, then we have the SoC and Wi-Fi chip, and then we have also the DDR2 RAM, and then also we learned how to get the data sheet, and we interface with the SPI memory chip and use bus pirate and flash ROM in order to dump the content of the memory. I hope you enjoyed in this video. In the next one, we will extract the Linux kernel and the root file system from the firmware. So thank you for watching, and see you next video. Bye bye.